1.7 Exponential Functions. So in this lesson, we kind of deviate a little bit from the radicals we've been studying, and now we're going to start talking about graphs when you're using exponents. This whole chapter has been about exponents or radicals, which is actually a fractional exponent. So now we're going to talk about what the graph of an equation that has an exponent in it looks like. So everything in this whole book will relate back to graphing, believe it or not. So let's talk about the graphs that we already know. Okay, so y equals 2x plus 1. What does this graph look like? Well, this is in y equals mx plus b form. So I know my y-intercept will be at 1. And I know my slope is at 2, so I go up 2 over 1. And I know that the equation will be a straight line. That may not be perfect, but you get the idea. So this is a linear equation, and it's a straight line. Also important to notice that the exponent here is a 1. It's a ghost 1, but it is there. It's a 1. It's the exponent on the x. Okay, now if I go to the second one should be a reminder of the end of the book. And the end of the book, the last book, was talking about things that were squared. So I had 2 times x minus 3, the quantity was squared, plus 4. So remember that that means it was a parabola. The 2 means that it's skinny and facing upward. And the vertex was at 3, 4. So 3, 4. And then I know that it's a parabola and it's pretty skinny going upward. Okay, important to notice that the x is squared. So yes, these do have exponents on them, but the exponents are numbers. Okay, finally, our last one was also from the last book. This one, we're dividing by x, right? We're dividing by x minus 2. So this, of course, was a hyperbola, or an inverse relationship. I knew I have an asymptote at x equals 2 and an asymptote at y equals 4. And I know that it's positive, so I know that I'm going to basically be in the first and the third quadrants. And so that, because I'm dividing by x here, it doesn't have an exponent, but I'm dividing by x, that's how I know it's a hyperbola. Okay, so now we're going to move on to a new kind of equation, an exponential function, and this is going to be when the exponent is the variable. Okay, so let's look at this problem. Grains of rice problem. You may recognize this problem from somewhere, but it's definitely in this lesson, so you'll see it again. A wise man earns a favor from his king. There's a whole storybook that goes with this, but in case you don't know it, the story will be retold in the lesson. But this is the quick version of it. A wise man earns a favor from his king. The wise man asks for some grains of rice every day. On the first day, he asked for 1 grain of rice. So if I'm going to put this in a chart. On the first day, so day 1, he asks for 1 grain of rice. On the second day, 2 grains of rice. 2 grains. On the third day, 4 grains of rice. Ooh. Then 8, then 16. So on the 4th day, he gets 8, and on the 5th day, he gets 16, etc. Can you see the pattern? He goes from 1 to 2 to 4 to 8 to 16. So he's doubling his grains every day. Okay? The king laughs at him and grants him this request. How many grains of rice will he earn on the 30th day? Well, the king laughs at him, and if in the context, the king is not very wise because he thinks, well, 1 grain of rice is nothing. But on the 30th day, you'll see he actually has quite a bit of rice. Okay, so how do I figure this out? Well, I know I'm multiplying by 2 each time, right? I'm doubling it. So this is basically talking about exponents with 2 as my base. So if I think about 1 in terms of exponents, I could say that is the same as 2 to the 0 power. 2 is the same as 2 to the first power. This is distracting, so I'm going to erase this. 4 is the same as 2 to the second power. 8 is the same as 2 to the third power. 16 is 2 to the fourth power. Okay, so if I continue to the 30th day, I don't know what it's going to be, but it's going to be a very large number. Okay, if I look at the day and then I look at my exponential version, the first day is 2 to the 0 power. The second day, 2 to the first power. The third day, 2 to the second power. The fourth day, 2 to the third power. The fifth day, 2 to the fourth power. So the 30th day will be 2 to the 29th power. Okay? And if you actually do 2 to the 29th power in your calculator, you will see it's a huge number. And I'll let you do that on your own. So actually the wise man's quite smart, and he ends up getting lots of rice, and the king ends up being very, very sad. So if I were to put this into terms of x, okay, on the xth day, how many grains of rice? Well, I went from 30 to 29, so I know my base is 2, and I'm going to take whatever day it is, and I'm going to subtract 1. So that would be the generic rule for this grains of rice problem. Okay, so if I want to look at, this is exactly what I just had, right? 2 to the x minus 1, and I wanted to put that in a graph form. Well, let's see what this looks like. On the first day, 1 grain of rice. On the second day, 2 grains of rice. On the third day, 4 grains of rice. On the fifth day, 16 grains of rice. So it shoots up very quickly, and it's a curve. Okay, it's called exponential growth. And if you take this down into the negatives, you will see that you get close to, but actually never cross over into the negatives. It's going to be, in the terms of days and grains of rice, it doesn't make a whole lot of sense, but in terms of algebra, I'm never going to get a negative value. Okay, because my base is not negative. So an exponential equation hugs the axis but never crosses over it. Okay, people talk about exponential growth in life. They'll say, oh, that grew exponentially. And what that means is they're saying it grows really quickly, not a steady rate like we've talked about in the past. So if I were to do y equals 3 to the x, okay, now there's no word problem to go along with this, okay? I'm going to put my x over here and my y over here, because when in doubt, I have no idea what this looks like. I'm going to make a chart. I'm going to start with 0. So I have y equals 3 to the 0th power. 3 to the 0th power is 1, okay? If I put a 1 in here, I have 3 to the first power. That's 3. If I put a 2 in here, I have 3 to the second power. That's 9. If I put 3 in here, I have 3 to the third power. That's 27. And this is getting pretty large. Let's take a break here. I'm going to put some negatives in here. What if I put in a -1? I have 3 to the negative first power. Well, remember, that's a fraction, 1/3. If I put -2 in here, I'll have 3 to the negative second power. Again, that's a fraction. That's 1/3 squared, or 1/9. If I put in -3, I'll have 3 to the negative third power. 1/3 to the third, I'll have 1/27. See how it's getting really small, but it's actually not getting negative. My x values get negative. My y values just get very small and fractional. So now let me graph it. Okay, 0, 1. Well, that's right here. That's easy. 1, 3. That's easy. 2, 9. That's easy. 3, 27. Well, it doesn't even fit on my graph, but I know it's like way up here. All right, what's happening at -1? 1/3. Ooh, that's hard. 2, even closer. Notice how it's getting close. I can't even graph it. It's virtually impossible, especially on this program, for me to graph it. But this, not very good, Cindy, is what the graph would look like. I don't like the way this looks over here, so I'm going to try and redo it. It's a curve, and it gets increasingly close to the axis, but never crosses it. Okay, now sometimes you have a negative exponential power, like 3 to the negative x. So again, I have no idea what this looks like. So I'm just going to make a graph. And I'm going to do negative values, I'm going to do a 0, and I'm going to do positive values. And later on in the book, you're going to actually do fractional values, but we don't need to do that today. So let's do 0 first. That's always the easiest one. 3 to the negative 0 power. Well, that's 3 to the 0 power, which is just 1. All right, I'll do the positive values. Those are usually easier. 3 to the negative x power, 3 to the negative first power, that is 1/3. 3 to the negative second power, that's 1/9. 3 to the negative third power, that's 1/27. This looks like it did before, except for before, remember, I had the negative values on the bottom and the positive values on the top. So let's go to this one. 3 to the negative first. Well, that's just 3 to the first, or 3. 3 to the negative second. Well, that's just 3 to the second, or 9. 3 to the negative third, that's just 27. So actually, this ends up being the other direction, okay? Let's see, 0, 1, 1, 1/3. So these are now my fractional values, notice, okay? And over here, I've got my so now it's kind of going the opposite direction. Okay, so when you have 3 to the negative x, it starts high and it ends low. It's like decreasing quickly. When you have 3 to the positive x, it's increasing quickly. Make sense? Okay, you don't have it here, but you're also going to be dealing with y equals -3 to the x power. And what that's going to do is that's going to be bringing it down into these lower quadrants. But again, when in doubt, when you don't know what a graph looks like, always make a t-chart. Put in values and plot points. It's the easiest way to solve any graphing questions. A t-chart, plug it in, get the values, plot it, and draw it. Okay, best of luck.